In this lesson, we'll solve a problem on algebraic methods to demonstrate an important technique when working with problems involving fractions. In this problem, we're asked to state whether or not the equation 1 over x to the minus 1 plus y to the minus 1 equals x plus y is true for all values of x and y. Now, eventually we're going to look at this expression algebraically or analytically, but to determine whether or not this is true for all values of x and y, we can actually get started just by plugging in some numbers for x and y. So let's choose some easy numbers to work with. Let's start with x equals 2 and y equals 3. What happens when I plug in x equals 2, y equals 3 on the left-hand side? I get 1 over 2 to the minus 1 plus 3 to the minus 1. And now let's just work through what each of these mean. Remember, when I have a number raised to the minus 1 power, that just means 1 over the number, so that my 2 to the minus 1 is the same thing as 1 over 2, or 1/2, and my 3 to the minus 1 is 1/3. So this becomes 1 over 1/2 plus 1/3. And now how do we add these two fractions in our denominator? So we'll get a common denominator in the denominator. So 1 over 2 is the same thing as 3 over 6. 1 over 3 is the same thing as 2 over 6. So these add to give us 5 over 6. So we get 1 over 5 over 6, which simplifies to 6 over 5. So for the values x equals 2, y equals 3, the left-hand side is equal to 6 over 5. What about the right-hand side? Well, x plus y is equal to 2 plus 3, which is equal to 5. These two quantities are clearly not equal to one another. So just by checking the expressions for two values for a value of x and a value of y, we're able to determine that this equation is actually not true for all values of x and y. And this is an important technique that I want you to keep in mind whenever you're dealing with algebraic expressions, whether it's fractions or square roots or exponentials or logarithms. If you're not sure if a step or an equation is actually valid, if you're about to try to make a simplification and you're not sure if what you have is actually correct, try it for a few values of x and y and see if you actually are getting an equality. If you are getting an equality, then you would need to try to explain why your equation is true. But certainly if you just try some values of x and y or whatever your variable is, and your expressions result in different values, you can definitively say that your equation or the step that you're trying to convert is actually not true. Now, to be complete, let's go ahead and just evaluate this more analytically. So let's go ahead and start with that left-hand side. What is 1 over x to the minus 1 plus y to the minus 1? Well, as we said, x to the minus 1, that just means 1 over x. And y to the minus 1 is 1 over y. Like we did with our numbers, let's combine those fractions. To do that, we need a common denominator, which in this case will be xy. So our 1 over x will write as y over xy, and our 1 over y will write as x over xy. We now have a common denominator xy, so we can combine those fractions, and we get 1 all over x plus y over xy, so that fraction in the denominator flips, and we get xy over x plus y, and we can see right away that that is not equal to x plus y. So again, we can see why analytically this equation is not true. But when you're working on a problem, if you're not sure whether or not something is true, it's easiest just to plug in some values of x and y or whatever your variable is to see what happens. And again, that's the technique that I want you to keep in mind moving forward. And of course, it's a good review of working with fractions to understand what we did here in this final analysis.